Okay, Kiana, this is part 2 of your vector addition lab. I made an error in part 1. I forgot to say that whatever your grams are for the vector, you have to convert that to kilograms, and you know how to do that. And actually, an easy tip is to just move the decimal 3 places to the left. Okay, so I did a quick example for you for finding the x component of the equilibrium vector. And so that's going to be your amount of grams converted to kilograms times gravity, which gives you newtons, and that's a vector, times the cosine of 49 degrees. And it's 49 degrees because the equilibrium vector is 49 degrees. So you calculate that, your answer's in newtons, and you can put it in your table. Okay, so now for procedure part 4, the data analysis, it says determine the percent error between the magnitude of R of part 1 and part 3. The true value is from part 3. And then for question number 1, it asks why the true value is part 3. Okay, so this is the formula for percent error, and you have that in your lab. Not maybe this lab, but maybe the previous one. I think that it was you that I was helping with percent error. So part 1 goes in the experimental and part 3 goes in the theoretical, and then you multiply by 100 and your answer is in percent. And the reason that the true value is assumed to be from part 3 is because in part 3 you used math to calculate it. So it is the theoretical one. It's the one that it should be in a perfect world. But in real life, whenever you're in the lab, working with pulleys and stuff like that, it's not a perfect world. Okay, so you're gonna do procedure part 4 data analysis, calculating the percent errors from part 1 and 3, and then 2 and 3. And I think I'll do one more video and that'll finish up this lab.